Hi all of you, quantitative ability, and the topic that we're going to have is numbers at one. A very important topic from CAT and that point of view. In some books, it's a subset of arithmetic. Some books just extend it along with LCM, HCF, averages in that series. At Bullseye, we have made a separate presentation, separate session of this. Advanced numbers is also called as modern maths in some books or some websites. What it has is it's basically having the basic operations like plus, minus, multiplication, division, but formed in very unexpected way. And we did not have it in our school days. That's why some websites or books call it as modern maths, and quite a few of them call it as numbers advanced. So what exactly we have in this is power cycle. It's to do with the string of multiplication and the last digit that behaves as per the terms one after the other. That's power cycle. Power is A raised to B is the power. And if it gets a repetition, it forms a cycle. So the name power cycle. Remainder theorem, it's also called as modulus theorem. How complicated divisions are simplified, that's what will be a part of remainder theorem. Factors related, there are few topics in this. The number of factors in the given number of odd factors in the given number of even factors, so on and so forth. So it's a parent set of all the questions that come in this arena. Factorials related, the number of trailing zeros and the number of twos and the highest power of threes and all these things that come becomes a family of factorials. And the highest power of n, it's actually an extension to something that I just said, factorials related, but also can form a question without factorials. So this is what is included in advanced numbers or the modern maths. So let's see one by one. So we're going to do this with some questions so that the theory becomes easy to understand and retain in the memory. Here's one question. What is the last digit of the given number? Last digit as in the number in the rightmost position, that is the units place. What is the number in the units place of this? So it's not very easy to multiply all of them, and why should we? One thing we understand, 821 into 922. Two ones are 2, and remaining all other steps that I carry, whatever I do, there will be nothing below 2. So the last digit will eventually end with 2, So let us not multiply it completely and play only with the units digit of this. That's what basically it says. So if this last digit is 1 and this last digit is 2, 1 into 2 ends with 2. 1 into 2 ends with 2 and the last digit is 2. No matter how big the actual number is, who cares and wants to know? All we want to know is the last digit, and the last digit is 2. With a big number like this, having the last digit as 2 and getting multiplied by 723, again 3 2s are 6, there will be nothing below 6. You remember a school multiplication system? Once you get this 6, there is nothing here, so it is going to act as the last digit or the units place as such. So 2 into 3 is 6. Similarly, 6 into 4 is ending with 4. 6 into 4 is 24. The last digit will be 4. 4 into 6 is again 24. So it will end with 4. 4 into 7 is 28. It will end with 8. 8 into 8 is 64. So it will end with 4. And 4 into 9 is 36. So it will end with 6. So any number that we get, 2 digit into 3 digit, 3 digit into 3 digit, whatever combination we get, if we are asked to find out the last digit, the end result of the multiplication of the last digit, you need to play only with the last digits. That's how it is, right? Just an extension to the previous question, it still relates to power cycle. Actually, the power cycle starts from here. Similar question, but here we have only 2's and as many as 25 times. 2 into 2, 4 into 2, 8 into 2, 16 into 2, 30. If I were to do it conventionally, I would have done it this way. But 25 is too much. So what we try and do is we try to observe a pattern. Something that we started in the previous question, we do the same thing. This is 2. 2 into 2 is 4. 4 into 2 is 8. 8 into 2 is 16. So I'll keep only 6 in my mind. 6 into 2 is 12. So I'll continue with only 2 because 1 goes carry and we have only 2 over there. 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, and so on. So what you are getting is a repetition 2486, 2486, and so on. So in power of 2, it can be string of 2 or any number that ends with 2. Right? It can be 22, 32, 42, as long as the last digit is 2 and you have all the 2's at the units place. If you multiply them, you have to get this cycle, that is 2. 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, so it ends with 6, and 6 into 2 is 12, and it goes on repeating. So there are 4 stops in one cycle of power of 2. How many do we have? 25 times. So it starts from here 1, 2, 3, 4, 5, 6, 7, 8, 12, 16, 20, 24, and 125. So this will end with 2. So if I count all the stops 1, 2, 3, 4 and wait for the 25th stop, the 25th stop is 2. It looks childish to count it this way. So what is the other way we will do is, we will simply divide 25 by 4. Why 4? Because there are 4 stops in one cycle. So there are 6 complete cycles and now we have 1 stop for the new cycle. So 6 complete dials, 6 complete cycle, and then we start from 2. So it acts as a 2. So even if it would have been 2 raised to 429, for example, we would have not dialed it those many times. 429 divided by 4, you will get the number of cycles, because one cycle has got 4 stops. 429 divided by 4, the remainder is 1. So you will again move just one place. Even here, the last digit is 2. So that is the power cycle of 2. So if this is the power cycle of 2, we have power cycles for all other numbers from 1 to 9. 1, anyway, anything raised to 1 is 1. But I just now wrote the power cycle of 2. I'll write it again. This is 2, 2 2s are 4, 4 2s are 8, 8 2s are 16. Power cycle of 3 will be 3, 3 3s are 9, 9 3s are 27. I'm just keeping 7 in my mind. 7 into 3 is 21 and 1 into 3 is again 3. Right? Then 4. 4 has got only 2 stops, 4 and 6. 4 raised to 1 is 4, 4 raised to 2 is 16, 4 raised to 3 is 64, 4 raised to 4 is 256. So 4 raised to any odd number always ends with 4, and 4 raised to any even number always ends with 6. There is no other number. These are only 2 stops in the power cycle of 4. 5, everything is 5. 5 raised to 1 is 5. 5 square ends with 5. 5 cube ends with 5. 5, everything ends with 5. Right? So 5 raised to 0 is obviously 1. Otherwise, everything that comes in the index of 5 leaves the last digit as 5. Same is for 6. 6 raised to anything except 0. 6 raised to anything ends with 6. So we'll not write 5 and 6. How about 7? For power cycle of 7, 7 raised to 1 is 7. 7 7s are 49. So keep only 9 in your mind. 9 7s are 63. So keep only 3 in mind. As such, it is 7. 7 7s are 49. 7 cube is 343. And further into 7, it's 49 square. That's 2401. But why are we doing this? It is 7931. So 793, and this is 1. And again 1 into 7, it is 7. So keep only the last digit in your mind. So that is for 7. How about 8? For 8, it is 8. 8 into 8 is 64. So I'll only enjoy the last digit. That's 4. 4 into 8 is 32. So I'll keep only 2 in my mind. And 2 into 8 is 16. And 6 into 8 is 48. So it's a cycle now. So we did 2. We did 3. We did 4. We omitted 5 and 6. They are very easy to know. We did 7. We did 8. 9 is this way. 9 raised to 1 is 9. 9 square is 81. 9 cube is 729. So like 4, even 9 has got only 2 stops in the cycle. So 9 raised to any odd number will always end with 9, and 9 raised to any even number will always end with 1. That's it. Right? So 11, 12, 13, 14, the last digits are same. So we have actually completed everything in the theory part of it or the knowledge part of it. That's what acts as the base of path cycle. Now let's see this question. 2 raised to 123. 2 has got 4 stops. So if I were to dial it, how many circles will be there? How many dials will be there? 123 divided by 4. The divisibility test of 4 says if you have to divide any number by 4, only divide the last 2 digits. So 23 divided by 4, the remainder is 3. So I have to move only 3 digits, 1, 2 and 3. So the answer is 8. 3 raised to 333. Even if it would have been 43 raised to 333, it would have been the same question. Had it been 93 raised to 333, it is same for me. I'll focus only on this 3 and that's what matters. 3 has got 4 shops similar to 2. So these 4 shops are there. So we need to see how many dials will be there in 333. So since one cycle has got 4 shops, divide 333 by 4. The remainder is 1 because I divided only 33 by 4. 4 8s are 32, so remainder is 1. So move only one place. So this is first stop. So the answer is 3. 7. How many stops does 7 have? 7 has got, where divided we write here 7. 7 has got 4 stops. 7 raised to 343. Divide 343 by 4. Why are we dividing by 4? Because there are 4 stops. 343 to be divided by 4. Focus only on the last 2 digits. That's 43 divided by 4. 4 tens are 40. You have got 3 as the remainder. So 1, 2 and 3. So the last digit is 3. 8 raised to 937. 8. Here's 8. Even here there are 4 stops. So 937 to be divided by 4. Eventually 37 to be divided by 4. 9 4s are 36. Remainder is 1. So we will move only one place, that is 8. What is the last digit of the 4 questions? Here are the 4 answers to these 4 questions. So all you need to know is this circle, and after that it becomes so very simple, right? You can make any complicated question of this type. You will only have to play with the last digits and keep only the last digit of that base. It's all over after that. This is slightly different. So the first 2 slides were the power cycle. Now here we have remainder. So the question is saying this divided by 17. What is the remainder? So by no means I can multiply the 4 terms. Even if I am given the calculator, it will be huge number. Maybe it will not be a 9 or 10 digit number. You look at that, it's big number. So what remainder theorem says is, if you cannot multiply all the terms, so instead of multiplying all the 4 terms and then dividing by the denominator to find the remainder, the better idea is you take the remainder in each case and then play with the remainders. So 148 divided by 17, what is the remainder? 17 8s are 136, so the remainder is 12. What did I do? I simply divided this. So that's 12. How about 231? 17 1s are 17, 61, 17 3s are 51. So here the remainder is 10. 12 is the remainder and 10 is the remainder. How about this? 17 20s are 340. So the remainder is 5. So I'm taking term by term. I found the remainders of these 3 terms. Now heading towards the 4th term. 17 4s are 68. Remaining is 91. 17 5s are 85. So the remainder is 6. Here it is multiplication, multiplication, multiplication. So even here I will multiply. 12 into 10 is 120. 5 into 6 is 30. 120 into 30, we can write it as 3600. But if you don't want to play with the bigger numbers, you can still go with bits and parts. 120 divided by 17. 17 7s are 119. So the remainder is 1 here. 30 divided by 17. 17 1s are 17. 30 minus 17. The remainder is 13. So 13 into 1. Finally, the answer is 13. Right? What is the remainder? When this number is divided by 17, our answer is the remainder is 13. Right? So play with the terms. If we would have had a different operation here, had it been plus here, we would have played with plus over there. If this was minus instead of multiplication, so 12 into 10 into 5 minus 6, we would have dealt the same way, the way the basic operations are in the numerator. That simple it is. What is the remainder? So again the similar family, but this time you don't have string of numerator terms. You have got only one term, but look at the size of it. 142 into 142 into 142, as many as 142 times, and that is to be divided by 7. So for you to understand what it means is 142, 142, 142, it is multiplied 142 times. There are 142 terms this way, and then you have to divide this by 7, right? So we will do the same thing that we did in the previous slide. We will find the remainder term by term. 142 divided by 7. 720s are 140. So here the remainder is 2. So will be here. So everywhere we will get the remainder is 2. So 2 into 2 into 2. How many 2's are there? We have got 142 2's. Now 2 divided by 7. It's already reduced. It cannot be reduced further. 2 into 2, 4 divided by 7. 4 is still smaller than 7. You cannot do anything more than that. But if you take 2 into 2 into 2, 3 terms, 8 divided by 7, the remainder is 1. So if I take one more triplet, the remainder is 1. So this way, if I go on taking triplets, I manage to reduce the size of the numerators. So how many triplets can be formed? 142 divided by 3. 3 4s are 12, 22, 3 7s are 21. There are 47 triplets. So 1 into 1 into 1 into 1, we will have 47 times, and one of the two will be without any set. It doesn't get other two partners. So 1 into 1 into 1, anything, any number of times you get 1, and finally you have 2. So 1 into 2, you get 2 as the final answer. The question was 142 raised to 142. What is the remainder? We don't know the quotient. No one knows that, but the remainder is 2 for sure, thanks to remainder theorem or the modulus theorem. Some other way of doing this was with the Euler's theorem. It might look redundant in this case, but in some other cases it might be helpful for you. So I'll just cover it here. What Euler's theorem says is, if the denominator, which is 7, is co-prime with the given number, that is numerator, 142 and 7, there are no common factors. 7 itself is fine, it's a prime number, so it cannot be having a common factor with any other number. It will be co-prime for sure. You will have to find out the number of co-prime numbers before 7. 6, 5, 4, 3, 2, 1. So the Euler number of 7 is 6. Right? So you first find the Euler number of this, and any number 142 raised to any index that is a multiple of 6 will always give a remainder 1. That's what Euler theorem says. We've already got the answer there. The answer is 2. We are just going on with some other way of doing this, and that's Euler's theorem. So what is the start of it? Ensure that the numerator and the denominator are co-prime. They are. Step number 2, find the co-prime numbers before the given number, that is before 7. There are 6 numbers that are co-prime with 7. 7 is a prime number, so every other number is co-prime with it. And then you write 142 raised to a multiple of 6. 142 is not a multiple of 6. So a number before that, 6 2s are 12, 22, 4 is a remainder. So 138 is a multiple of 6. But that's 142. So I'll write the remaining 4 here. Now, this being a multiple of 6 leaves a remainder 1 by all means. So you have to play only with this. So what you are left with is 142 into 142 into 142 into 142 divided by 7. So here the remainder is 2, here it is 2, here it is 2, and here it is 2. 2 into 2 into 2 is 16, and 16 divided by 7, the remainder is 2. The other way of doing. I know you might find this one is easy, but there will be some questions where the denominator size will be huge. It's 23 or maybe 129. Euler's theorem will really be helpful in that. So that's remainder theorem. What it simply says is you can take term by term of the numerator, reduce the term by finding a remainder smaller, remainders are a lot smaller than this, and then play with the smaller numbers and get down to the answer by this, the END of sorts. Now this is the third topic. We did power cycle, we did remainder theorem. In remainder theorem, the conventional modulus theorem and the Euler theorem. Now we have the factors related theory. How many factors are there in 24? What the question means is, there are how many numbers that find 24 in its table. So if I do it by brute force method, 24 कौन से टेबल में आता है? 1k, 2k, 3, 4, 6, 8, 12 and 24. These are the factors of 24. Am I right? 1, 2, 3, 4, 5 is not a factor of 24. 7 is not a factor of 24. 9 is not a factor of 24 and so on. So 1, 2, 3, 4, 5, 6, 7, 8. The answer is 8. But the number 24 is very small. I can afford to do it this way. If the number is huge, I can't do it this way. So what mathematics says is, write 24 as a product of prime numbers. So 24 is 12, 6, 3. There are 3 2's and 8 into 3 is 24. So for you to find out the number of factors, just add 1 to this. This is 3 plus 1 into, add 1 to this. This is 1 plus 1. So you get the answer as 4 into 2 as 8. And these are the 8 factors. So even if the number is bigger, it doesn't matter. If the number is 240 for example, big number, 24 के बाद सीधा 240. How do we write 240 as? 120, 60, 30, 15 and 15 is 3 into 5, 15. So I broke 240 as the product of prime numbers. 4 plus 1 is 5, 1 plus 1 is 2, 1 plus 1 is 2, 4 into 5 is 20. There are 20 factors of 240. No need to write which all are there, but these are 20 factors. Right? So that's the answer to the total positive integral factors of the given numbers. Moving on to the next question. What is the next question? It's asking what is the sum of all these factors. How many positive integral? Alright. It is asking the positive integral, number of positive integral factors, but this time not all, only the odd ones. So I'm again writing 24 is, the factors are 1, 2, 3, 4, 6, 8, 12 and 24. Did I miss anything? 1, 2, 3, 4, 5, 6, 7, everything. How many odd factors are there? This is odd, this is odd. That's it. So the answer is 2. How many even factors are there? The answer is 6. 8 minus 2 is 6. How do we do it mathematically? 24 is written as, right? So for you to write the odd factors, do not take this. 2 is the only prime number. So apart from 2, all the other prime numbers that you have, play with it. So it is, this is 1 and 1 plus 1, that is 2. There's nothing more. Had there been 5 at the same time, would have actually multiplied that. So in 240, what did we have? 16 into 15 is 350. How many odd factors are there? If that is the question, I'll ignore this. This is 1 plus 1, 2 and 1 plus 1, 2. In this case, the answer is 4. There are 4 odd factors, right? 1, 3, 5 and 15. These are the 4 odd factors. How about even factors? Total 8, 8 minus odd is even. That's one simple way of doing it. Otherwise, what we can do, if you want to know the mathematical way for it, just don't add 1 to it. For even factors, what do you do is, this is 3 as it is, and here you add 1. That's 1 plus 1. So 3 into 2 is 6. How many even factors are here? Write 4 as it is. Do not add 1 to it. 1 plus 1, 2. 1 plus 1, 2. This will give you the even factors. 4 2s are 8, 8 2s are 16. 16 even factors, odd factors are 4, and the total factors, if you remember, in the previous question we did, they are 20. 5 2s are 10, 10 2s are 20. So that is how you find out the odd factors, even factors, total factors, right? Okay, what is the next slide? What is the sum of all these factors? 24, again the same number. What is sum of all factors and what is the sum of all the even factors? So let's do it with the brute force method first. 24, 1, 2, 3, 4, 6, 8, 12. 1, 2, 3, 4, 5, 6, 7. One number I missed out. 1, 2, 3, 4, 6, 8, 12, and this is 20. 8 factors. What is the sum of this? 24 and 6 is 30, 30 and 20, 50, 50 and 10. The sum is 60, right? No big deal. How does maths come ahead and help us out? It says you again write 24 in the prime factors. This is 8 into 3. And then you write all the factors of 8, that is 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 and 2 raised to 3 also is a factor of 2. It ends with 3 because 3 is the highest one. For 3, it will be 3 raised to 0 plus 3 raised to 1. So this is 8, 8 and 4, 12, 12 into 14 and 1, 15. This is 8, this is 4, this is 2 and this is 1. So that's 15. This is 1 and this is 3, so that's 4. And 15 into 4, we get it as 60. So that's the sum of factors. What is sum of all the positive odd factors? In this case, we don't take this 2 raised to 0 here. We ignore the even number 2 raised to 3 and we take only the odd. So this is 3 raised to 0, which is 1, 3 raised to 1, which is 3, and 3 plus 1 is 4. I write it separately. For odd factors, it is, ignore this, only take this 3 raised to 0 plus 3 raised to 1, that is 1 plus 3 and that is 4. And here it is 1 and 3, that is 4. All others are even numbers. Yeah. What is the sum of all the even factors? One ideal way is this is total 60. 60 minus 4, that is 56. But if you want to know the maths behind it, keep it as it is. Only omit this 1. So that is 8 into 10. 10 plus 4, 14. 14 into 4 is 56. Let me write it separately here. So 24 is 8 into 3. For sum of even factors, you don't take 2 raised to 0. You start with 2 raised to 1, 2 raised to 2 and 2 raised to 3, and this is 3 raised to 0 and this is 3 raised to 1. So this is 2 plus 4, 6, 6 and 8, that's 14, and this is 1 plus 3, that is 4, and 14 into 4 is 56. Ideally, you can know the way of finding total number of sum of total factors, and you know odd, so total minus odd is 0. But just that if you want to know what is the maths behind it, this is it. So that is summation. This is that family of factors and factors related question. See, the questions that we are doing it here, this session is not ensuring that these sessions are very likely in the coming CAT and ZAT exams. But we are saying this acts as a base. This is the raw material with which CAT will come up with some, questions where you need some other ideas. So you can't afford not to know this. But that doesn't mean if you know this, your number system is over. You'll get to know in the mocks or the sectional test how this acts as a base. So the session is more of base building. What is the highest power of 2 in 10 factorial? So let's first do it with the brute force method. 10 factorial is what? 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. What is the highest power of 2? What that question means, how many 2's are there? For example, in the previous question 24, we had 3 2's, 2 into 2 into 2. So that way, in this huge number, how many 2's are there? If you try to actually locate this, this is 1 2. 4 actually is made up of 2 into 2. So this is another 2. 6 is 2 into 3. So this is 1 2. 8 is 2 into 2 into 2. So we found out 1 2. 10 is 2 into 5. Right. Altogether, if you see 1, 2, 3, 4, 5, 6, 7, 8 2's are there. Why was I circling only 1, 2? You will now understand. What is the idea? Because 10 is a simpler number, a smaller number, we can do this, but bigger numbers, we can't write it this way. So let's do the experiment with 10 factorial, get it drilled very well in our head, so that even if the question deviates slightly from the given question, we already know how it gets formed. We will be ready to adapt and change. So first find out all the even numbers in 10. There are 5 even numbers, 2, 4, 6, 8 and 10. 1, 1, 2, 3, 4, 5. So we found out 5. In the second round, find out the multiples of 4 because 4 has got 2 2's. We located only 1 2. How about the other 2? So 10 divided by 4. Now this 2, 1, this 2, 2. So there are 2 2's. So this is only the quotient. 10 divided by 4, 4 1 the 4, 4 2's are 8. There are only 2 4's. By finding 2 4's, we find out the 2's that got missed in the first round. There were 2 2's. We located the single 2's and now it is second 2's. And then we divide by 8 because 8's are made up of 3 2's, 2 into 2 into 2. So in the first round, we located 1. Second round, we found out the multiples of 4. So the hidden 2 was found out. 8 has got 2 into 2. So in the third round, we see the third 2 and 8 divided by 10 divided by 8, the quotient is only 1. So 5 plus 2 7 plus 1 8 and that is what we have. We actually found out 8 2's. Haath kangan ko aarsi kya? You don't need maths to find out the number of 2's. Here they were 8 2's. But how mathematically we understand it, this is the proof behind it. Now, instead of 10 factorial, even if somebody gives us 100 factorial or 1000 factorial or 10 crore factorial, it's not too different. The logic is the same. I can't write numbers for 100 and bigger numbers, factorials of those, but the ideas will be same, so the hard work won't be too much. What's the highest power of 3 in 10 factorial? Now, for 3, what we do is, we try to find out 3's the way we found out 2. So I'll take the effort once again. 10 into 9 into 8 into 7 to 6 into 5 into 4 into 3 into 2 into 1. Don't do this in the exam. I'm just deriving it by brute force method so that the idea gets drilled in your head. And if the question deviates slightly, you are really in a position to change from there. So 10 divided by 3, there are 3 3's. Which are those? 1. Here there's one more. 2. And here's there one more. 3. And then divide 10 by 9. Why? Because we want to find out the hidden 3. And here's the other. That's it. No more 3's now. So the answer is 3 plus 1, 4. There are 4 3's in this. What is the highest power of 6? If you try to do the same thing, 10 divided by 6 plus 10 divided by 36, this anyway is not there. 10 divided by 6, it is 1. Is the answer 1? It is not. Sure it is. There's 1 6, all right. But this 3 into 2, this is also a 6. Come on. There's 1 3 here. And then it multiplies with one of the even number, it gets one more 6. So when you divide it this way, you ensure that you divide only by prime numbers, because prime numbers cannot be broken, and 6 is not a prime number, so you cannot go that way, right? 2 was a prime number, so 2 cannot get formed by some other merger. 3 is a prime number, no two numbers multiplied to itself will form 3. 3 is a prime number. 6 is 2 into 3, so you cannot just pluck 6's. 6 gets formed some other way also. So what do? We find out the number of 2's. We had 8 2's in 10 factorial. How many 3's? Uh, there are 4 3's. So you have got 8 2's. 1, 2, 3, 4, 5, 6, 7, 8. And you have got 4 3's. So how many 6's will be there? 3 into 2, this is 1 6. 3 into 2, this is the other 6. 3 into 2, this is the other 6. And 3 into 2, that's the other 6. So we could manage to get 4 pairs. So the highest power of 6 is 4, right? Simple way of dealing with it is the minimum of the two decides the maximum pair. So for example, in BYK, there are 400 girls, and in the same BYK, there are 800 boys. 400 girls, 800 boys, and a project will be given to a pair of students, but the condition is it should be one girl and one boy. Only a set of one girl and one boy will get a project. There are 400 girls, let's say, and there are 800 boys. We will be able to give only 400 projects because the remaining boys will have no partners. That's called minimax technique. The minimum number decides the maximum pairs. So no need to do this. This was just to convince you because it's a session of basics. But 8 and 4, 4 is the minimum, so 4 pairs will be there. Finish. Right? So if you want more videos of this type, don't forget to subscribe our video and press the bell icon. You will get quite a few videos of this type. There are enough bits available in the link here. Helpful information is there in the link given below. And wait for the next video. We'll come up with one more basic topic of this type. Thank you very much.